Hello, everybody. May I ask for your attention? So this is the sort of infamous last session before lunch. So I'll try to make it quick and entertaining so I don't sort of end up encroaching on the lunchtime. I hope everybody I hope that everybody had their morning coffee and they are well tired by going through some theory, because there will be actually little theory in this talk. And modulo some AV problems, let's start. So my name is Jakub. I'll be talking about running some serverless functional programming on top of Microsoft Azure. There will be a little bit of Haskell here and there. And as I said, there will be little theory and fancy types here, mostly due to the engineering nature of this talk, and also everything presented here is a very much work in progress. And I kindly ask you to ask questions during the talk, because I will encourage some dialogue, because then I know that you at least understand what I'm saying. Because because if you just sheepishly look at me, then I have absolutely no idea whether you understand what I'm saying or not.
Question?
Yes?
What do you mean serverless?
What does, sorry?
What do you mean by serverless?
Okay, I'll explain that. I'll explain that. But essentially, serverless means that you don't have the control of your server. As a rough idea, that you either provide your files or you provide a container, and your cloud provider handles everything else. I'll show you some more precise definition later. Okay, so maybe a quick question. Has anybody of you used Azure Functions or Lambda or Amazon Lambda or, okay, one person. Okay.
I haven't, but I know what it is.
Okay, so yeah, so I guess you should know. So yeah, and a quick intro little about me. I do programming languages theory in Haskell and sort of pen and paper. So Lambda calculus style writing proofs of paper that don't necessarily get translated to programs, because in some cases that will be too difficult to do so. And I also work by doing machine learning and signal processing in Python and .NET. So this is sort of trying to bring these two, because we actually, on my work, we had some workflows that look like they would match Haskell really well, and we actually tried to figure out how difficult it would be to sort of transition some of our workloads to Haskell. And yeah, sometimes it's a bit difficult from the engineering standpoint. And yeah, so, and this talk is essentially more of a record of what I tried, or where were the sort of pain points, together with sort of showing you what's actually the promise of serverless for some of you that didn't or have no experience with Azure Functions at all. And yeah, it doesn't really fit, but okay. Quickly open the image in new tab, which doesn't show here. So essentially, answering your question, what is serverless, is essentially giving full control over your server to somebody else and just providing either your application as a set of files or as a container. And the advantage of that is that you sort of abstract over the notion of your server. In some cases, you also abstract the notion of your sysadmin, because you sort of offload your sysadmins to your provider and to the cloud. So you only maintain your application, and preferably the set of dependencies that come with it, and both the runtime that your application will be running on and the server is maintained by your provider. So in a way, you don't need to worry about patching, maintaining, but also scaling. Okay. And one good definition I heard is essentially spinning up a container per each request or event. Because one thing that serverless sort of implies behind the scenes is that you're not certain about your persistency. I mean, some providers offers you some persistency layers for your serverless instances, but most times you don't have any guarantees of your file sticking around. So it's so sort of, in a way, it matches nicely to sort of pure functions or stateless functions. And as I said, the promise is that you don't need to worry about maintaining your instances. That you have almost automatic scalability. In some cases, you have a slider or essentially you set up a value of your instances similarly to how platform as a service offerings work. So say that today I want to run on free virtual machines or free instances, and I hope that will be enough of computing power to handle my workload. But in other cases, I mean, there are some offerings that will simply provide you with auto-scale functionality. So they will sort of increase the amount. They will increase the amount of instances and automatically provision them as the need arises, and then sort of deallocate them as the traffic diminishes. And sort of the biggest promise for doing that from company standpoint is that it allows you a different cost model because you only pay for what you use. So on Azure, in something called consumption plan, you only pay for the amount of computing power your code actually takes. So if you have a workload that runs every hour or so or once per day, and you don't need to pay for all these instances sitting idle, they're just waiting for an event. You only need to pay for that computing time while your stuff is actually doing something. And as I said, there are two flavors of serverless. Today I'll be focusing on today I'll be focusing on one, but tomorrow I hope to sort of show you some examples of the other. The first one is one when you bring your own files. So say it works really nicely with scripting languages, but actually it can work with any binary. Is that you upload or you deploy your application as a set of files that sit around, and you ask the runtime to run those files per every event. May it be an HTTP request, may it be a message arriving on the queue. We'll later see that there are various available triggers out there. And the other one, which is getting more steam recently, is that you bring your own container. So you sort of package your application with everything. You push it to some sort of container registry, and then you ask it to be run every now and again, or or as an effect of an event arising. And this one is bringing your own files is easier to set up because you just need to sort of give your files and deploy. In most cases, having a zip deploy works really well. For instance, when you plug it to a continuous integration and continuous deployment pipeline. Bringing your own container is more stable, especially if you have some wonky third-party dependencies, because you have more control about whatever is available in the system. And yeah, as I mentioned, I'm a net developer. Unfortunately, the reason there will be some .NET code in the talk, and some of the demos will feature .NET code simply because it's easier to show to them, and simply because I have not figured out how to make them all run in Haskell yet. And for those who are not into sort of .NET world, there is something called .NET Core, which is a cross-platform .NET framework from Microsoft. It's available on this link. And I'll be showing you how to sort of work on top of Microsoft Azure. For me, it's necessity because I work in a company that's 100% exclusive on Microsoft Azure. It's one of the perks when your boss is a Microsoft MVP. Whether it's a good match or a bad match for these workloads, I'm not sure. Probably there will be a person in the audience that will look at what we'll be doing next and tell me that if I went with Amazon Lambda or something else, it'll be way easier. But as I said, I had to. I mean, we were looking into sort of figuring out how to run some Haskell workloads on top of Microsoft Azure. And as I mentioned, there are multiple offerings. So the one I mentioned is Azure Functions. So this offering has actually pretty complicated. I mean, Azure Functions is an interesting offering, but it has a pretty heavy runtime that you need to play nice with. Then there is Azure Container Instances, where you just give it a container and ask it to spin it up. Then the sort of Microsoft Flow and Azure Logic apps are also considered serverless offerings, but they're not necessarily products aimed at developers. They're sort of really easy. So these are sort of things when you want to put together some really simple things. Say in Logic apps, you want to send an email in response to an event, and so so a person who is not necessarily a developer can create those. And web jobs is an old offering that sort of got evolved into Azure Functions. And as I said, we'll be focusing on Azure Functions and Azure Container Instances. Okay, so first thing that we'll look into, Azure Functions. So these are functions as a service, which have been mentioned multiple times today, where you specify a function that's supposed to be run to whenever something happens. So we will look at the list of triggers later on, but they suppose both bring your own files and bring your own container model. They have plans that run Windows instances or Linux instances, and out of the box they support .NET languages, JavaScript, and Java. And so in ideal world they would support Haskell, but then this talk would not exist. So we will look into how we can actually fix that, hopefully, or at least start fixing that. So there are actually two versions of Azure Functions available at the moment. There's something called V1, which is the stable version, which has been around since, I believe, 2016. And we'll be looking at something called V2, which is a version that's currently in preview. Hopefully, it'll be stable later this year. It's built on top of .NET Core, so it's cross-platform. V1 runs on Windows only. And the nice thing about this being cross-platform is that there are DevTools available for Windows, Linux, and macOS. So you can actually run an instance of your functions locally on your machine. The nice thing about it is that if you want to, it permits some interesting workflows when the version of your function, if the code that you deploy to the cloud is misbehaving, you can actually pause that workflow, start a workflow locally, and see how it works. Because again, ideally there should be little state associated. So whenever you start a version locally and then start the version in the cloud, they should behave and hopefully in the same way. So they also support remote debugging, but it does not always work perfectly, and mostly requires the latest Visual Studio, which is a resource hog. B, actually, I mean, they've been working on it and improving it, but quite often it fails to sort of interrupt, capture the breakpoints when you set them locally. And I have still been sorry. And I have not been able to sort of figure out how to debug things remote. I mean, debug remote deployments in a reliable way. So the runtime that's running on the server is open source, is available on GitHub. It's written mostly in C#, so I presume that most of you will not want to look into that too deeply. But the things that it provides out of the box is it provides a nice set of bindings and triggers, so you don't need to program them yourself. It does some basic logging and monitoring, and it will actually restart some functions if they fail, and it provides some nice automatic backup if a function continues to fail in a response to the same event. So the development tools are called Azure Functions Core Tools. You can install them via npm. So it's not the JavaScript. So they're not written in JavaScript, but they are distributed via npm, which is a sort of thing that Microsoft started doing recently. So if you have a latest version of Node, you can install them using this command, which is essentially npm install-g Azure Functions Core Tools at core. So this will install the sort of cross-platform version, and some versions of Node require to set unsafe perm to true. On macOS, you can use the homebrew tab. If you just brew tab Azure Functions, then you can run brew install Azure Functions Core Tools, and it will download the latest version of Azure Functions Core Tools. And yeah, so so that's regarding the development tools. Now, regarding the sort of persistence layers that are available to you. So Azure Functions play really nicely with the Azure storage offering available on top of Microsoft Azure. And probably by the end of the day, I'll say the word Azure way too many times. But essentially, there are 4 storage offerings. There is a file storage and blob storage that allows you. So this one allows you to store files in a more organized way. So you can actually connect to it in the same way you would connect to a remote disk. Blob storage is at the moment fairly similar to file storage. The only difference, I believe, is that file storage will allow you to have nested structure. You can actually connect to blob storage using an adapter that will treat it as a remote disk. There is a queue storage that allows you to use Azure queues, and there's a table storage which provides some column-based storage. And the reason why I'm talking about this is that Azure Functions provides a nice set of triggers and bindings for them. And so there is an Azure Search emulator available. Unfortunately, the one provided by Microsoft is Windows only, but there was somebody who actually wrote an emulator in Node, and is currently has been officially sort of taken under Azure mantle, so you can install it. It's called Azurite. So you just do npm install -g Azurite, and then you can actually develop everything locally. And let's switch to sort of first demo when I show you how to sort of bootstrap your first Azure function and start with it. Okay, so okay, so can everybody see the text on the screen?
Maybe you can make it a bit larger.
Okay. What about now?
It's fine for me.
Okay. So you will require, for searches, you will require 3 things, which sort of were listed here. You need to install latest .NET SDK, because some of the parts will be written in languages that are running on top of .NET. You need to install Azure Functions Core Tools, and you need to install Azurite. So for those that want to participate, I'll give you some time to install those. If anybody has any issues, may they raise their hands, so I'll approach them. I'll grab a water in the meantime. Oh, sorry. Yep. Hmm? Oh, sorry. Okay, is everybody ready? Or is there... Okay, so... So does anybody need some assistance? Yep.
The first command mine failed actually. npm I Azure. This command failed.
Hey, your internet doesn't work.
No, it works.
Can you ping something?
Yeah, it works.
What's your node version?
Tried, but what is npm Synacore? Do you have like a custom config for npm? Like
Yeah.
so can you maybe remove the, because maybe you like in npm rc, can you comment the custom config?
Actually, I don't know much about Node.js.
Oh, so you don't. So you don't have a custom Node.js configuration.
Yeah,
you have a
but his node version is a bit
Re-
old because it's 614.
Yeah, also that's not. Do you have npm maybe?
Yeah.
I thought the latest version was for all.
Can you check a Node version?
Yeah, sure.
Like just Node dash version.
What is it?
Node
Right node.
dash version. Yeah.
Okay. So...
Doesn't work. Actually, my
So
knowledge
that's-
in Node.js fails.
So that's Mac, right?
Yeah, this is Mac.
How did you install Node? Using Homebrew or using...
I think for our project actually we needed a little bit old version of
Ah,
Node.
okay.
So they asked me to specifically give a link and asked me to install. When I installed on my own, it was around some 8.8
Oh, so,
version. So they gave some specific link
But-
and asked me to install a bit older version.
Yeah, but since you're on Mac, you can just use brew tap Azure functions and brew install Azure functions core tools. You don't need to...
Oh, we can use either one of them. We don't
Yes,
need to
yeah.
use. Oh, okay.
So the top one is for Linux.
Okay.
Powinien być. Gardło mi trochę siada, bo nie jestem przyzwyczajony do tego, żeby tyle mówić.
Stresuj się na klimacie. Akurat kopiuję jeszcze.
Yeah, I think it's successful.
Numerowym komputer się usypia. Yeah. Sorry?
What do I do? I installed Node, but
Mhm.
I don't find npm.
How did you install Node? Then you don't have npm. You need to install it separately.
Okay.
That's weird because
Doesn't mention anything.
it might be. So did you install using apt-get?
Yeah.
So I presume there is an apt-get for npm.
Yes. Okay.
It looks like apt-get install npm should work.
Okay.
Yeah.
I'm trying that now.
I have Node.js installed, but it still says Node not found, so I'm not sure what.
Is Node in your path?
Like Node itself, not, but Node.js is. So.
So is Node on Linux a link to Node.js instead of Node?
I don't know that. Yes.
What Linux version is
Ubuntu 16.
So node command is linked to another program called also node. You have to install Node.js, something like that.
Okay, so which package is causing problems? Azure or Azure Functions Core Tools?
Azure Functions Core Tools.
So there, if you go to Azure Functions Core Tool website, so just Azure Functions Core Tools, I think there is an Ubuntu package, second link.
Oh, sorry. This one?
Yep. If you scroll down, there should be, there is link to, yeah.
All right.
Okay.
Thank you.
Okay, so everybody, whoever is using Ubuntu, apparently there is a bit of a clash between Node.js and Ubuntu, and for Azure Functions Core Tools, if you go to this GitHub account, so that's github.com/Azure Functions Core Tools, there are some additional directions how to install Azure Functions Core Tools in Ubuntu from Ubuntu package. So let me just. So yeah. So these are the directions. So apparently you need to register Microsoft product key and then add Microsoft apt repo to your sources list. It works. Did you manage to install Azure as well?
I installed, yeah, this one I installed.
And what about Azure?
Azure, no, not yet actually.
So if you just
How can I, oh.
so if you just do npm install -g Azurite.
What?
Azure, yeah. character was not amused. Dobra, ten to chyba musi instaluje.
Something.
No, ignore these things.
Yeah.
Czy NPM zawsze tak długo zajmuje?
Czasem wolno łączyć.
A, dobra. How are you guys going?
I just installed the Azure function score tools, but now I still have to do the two others, and I'm trying to figure out how.
.NET Core.
.NET Core I also have.
So the last one is Azure, right?
Yeah.
And I think it's just npm install npm I -g Azure, right?
And hopefully it will
Seems to be working.
Yeah, but it did that
Oh,
as
it complains later. Huh?
Yeah.
Is anybody else having some difficulties? Okay. Okay, go brew, unlink, no, just do brew unlink node. Yeah. Node at 6. Node at 6. Okay, now it will unlink the old version of node.
Okay.
If you want to enable it again, you need to do brew link node at.
Okay.
Now do brew install node. This will install the latest version of node.
Okay.
If you want to switch between them, you need to unlink one and link another.
Okay, got it. Okay, yeah.
So this way you will be able to use npm to install
Latest version on.
the Azure, yeah,
Oh, yes.
install Azure, right, and then you can sort of switch between them.
Okay. And so it's Node 10.
Yeah, the most recent version is Node 10.
Okay.
Thankfully, they're available as bottles, so it's easy to. So yeah, if you want to go back, just brew unlink node, brew
Okay.
link node at 6, and that's.
Okay, yeah.
A gdzie jedziesz, że potrzebujesz ubezpieczenia? A to nie wystarczy ci ten EQUOS?
Nie, bo Polska pokrywa tylko do wysokości świadczeń w Polsce.
A.
Około 0. Z grubsza.
This should work now. Już myślałem, że się włączył ten alarm przeciwpożarowy.
What's that? It's funny you asked about the similarity to the German language, because German and Polish actually
Mute.
the language of the people who cannot speak
Yeah.
the language are so different.
Okay.
Yeah, they're actually called mutes.
Actually, in India we have a lot of languages, but they have at least 30% similarity between each other. Yeah. Oh, even this is also failed now. Jacob.
Yeah.
Yeah, this
Is it still failing?
Yeah.
Oh, sorry, that's
So any
oh.
kind of node installation, basically.
That's a different.
Oh, still it is 6 version only.
Really?
Yeah, you probably have to
Someone's
I
installed.
think I have
try
to.
opening a new terminal.
Yeah, open a new terminal. It might have cached the things.
Yeah.
Just do command
I
T.
have to do this command.
Yeah, it's not in
actually.
path. Yeah.
If
No,
if
no,
I
no.
don't do it,
That's
no.
ICU4C. That's the different one. Open,
yeah.
open it.
Open a new terminal. Yeah. And try now node version.
No. Yeah.
So it
Type
must
in
be
which.
earlier in the path.
Type in which node. Which node? Ah, that's weird.
Have you modified your path?
Type in echo $path. Echo $path. Tak. Okay, so
So this is hard to code. Is this what kind of terminal is it? Is it Bash or is it?
I can.
that's bash.
That is Bash.
That's may I?
Yeah.
So this will temporarily add whatever is in user local bin, and now the node is whatever node is in user local. But it will only work in this terminal.
Okay.
It will not adjust your current config.
Okay.
And if you do which npm,
Which node?
it's the one here, and if you do, it should work now. That's weird.
Try pinging something.
It's working.
No, on może mieć. Ma customowe ustawienia tego serwera npm-u, bo to jest jego npm, serwer npm-a.
Tak?
Tak, bo do you work for a company called Synacore?
Yes,
Yeah.
Okay, so they have. So you have a custom npm.
Let me try to connect to their VPN.
Yeah, it should work once you connect.
Ale może cały czas nie mieć tego Azurita na tym rejestrze. A potem jego zespół IT będzie nas ścigał, czemu to. No nie, no powiem powiem, żeby nie czekali, nie?
No, myślę, że tak.
Okay, sorry everybody for the delay. Co? No, mówię, że ten. Sorry, everybody. A colleague of yours had some issues with NPM that were unforeseen. We'll stop for now because now there's lunch, and I don't want to eat. I mean, I don't want to eat in your lunchtime. No pun intended. We will continue after. What time does we return? 2? 2:30. Okay. So yeah, so these are no C packages. These are C#. So these are actually .NET DLLs. So that's why they're cross-platform. So in a way, yes, it's interesting because when you think about it, it's difficult to find cross-platform sort of package distribution tool. In a way, NPM is the only one that's popular enough, I guess. Yes, and also, yep.
They're rewriting Office 365.
Yes, I saw that news. Well, so they have huge sort of Electron investment and huge JavaScript investment because, Microsoft Teams is written as a JavaScript app. VS Code, I think, is sort of a prime. Yes, Electron is a prime example of sort of doing a JavaScript desktop app that works well because it is one of the sort of nicest text editors I've used so far. I was amazed because it was able to handle some files that Vim and Emacs were not handling properly out of the box. Then, yeah, there's also one more thing I would like you to install, and that's called Azure Storage Explorer, which is also an Electron app. So I think it should be fairly easy to install, hopefully.
I'm going to have to quit Teams in order to have enough RAM to run that.
Ah, okay, then, I mean, it's not necessary, it's simply to, yeah, but in a way, yes, that's another problem, right? Like, Intel is going to release a new 28-core CPU, and it's going to be great because I'll be able to run 2 instances of Electron app side by side. Yeah.
At least they're using React Native for Office 365, though.
Yeah, but there's well, there's still JavaScript running under the hood, right? Hopefully it's better. Frankly speaking, I cannot comment because there's been a sort of UI has been a bit of contention point in sort of .NET space because there's one that works. So there's Xamarin that works on mobile, sort of works on mobile. There is a UWP that sort of works on desktops, but there is no really one that works cross-platform well enough. So it is a bit of a shame that we've been like it's 2018 and GUI is still an unsolved problem. So yeah, going back to the things. So there's one more thing that I added to the list, which is Azure Storage Explorer, which is not necessary, but it's nice to have because it actually allows you to peek and see what's in your storage, what's currently stored in your Storage Explorer. So going back after the break, has everybody installed at least first 3 things? Because those will be crucial. So so now's the time for live coding session, and hopefully everything will go well. So if we make an empty directory, so there's nothing here, we can we can create something called function app. So the tool that we'll be using from Azure Functions core tools is called Func, and it has a lot of options, but we'll start by initializing a new function. And by default, it will ask. So by default, it will work in the current directory, and it will ask you to select worker runtime. So I'll talk about it later, but they're trying to rework the way Azure Functions supports different programming languages. So at the moment, it has a worker for .NET and a worker for Node. Currently, they're testing a worker for Python in preview. In a way, once the AP stabilizes, it should be fairly straightforward to extend Azure Functions runtime with a worker for a language of your own. The problem is, at the moment, the API is still a bit in flux because it is unstable, and it's they are changing it from every now and again, and also it's a bit difficult to have to design some sort of generic API for a sort of general API for having for loading functions in a different language. We will start with a .NET 1. So one, and so it should. So it will generate actually 3 files. Actually, more than 3 files, but 3 that are important. So one is host.json, which contains definition for the host, and actually here it will be an empty file, empty JSON file, meaning we'll use all defaults. Then we have something. Then we have a file called local settings, which is a file that contains settings that will sort of. These are settings for the sort of Azure Function app that we will start. This file is sort of, you can see here, it's encrypted false. It's interesting because this file is supposed to store all the necessary API keys that we'll be using for communicating with various services like Azure Storage or database or whatsoever. As you can see, we'll be using development storage here. So I will use the default one provided by the emulator, and they actually provide tools so you can easily download the settings from a deployed app to your hard disk drive, and by default those things are encrypted, so you cannot actually see them. I mean, you will get some garbage that will be protected by a key that's that was generated for your machine. You can ask it to decrypt. Usually, I mean, by default, this file is not committed to. I mean, it's ignored by a GitHub repo. And the third important file is in VS Code folder, because it will for all people that use VS Code, it will actually create a VS Code file that will that will include a list of recommended extensions. So if you were to open VS Code in this folder, it will automatically ask if you wanted to install VS Code extensions for Azure Functions, which is a bit of a nice touch when you're sort of trying it for the first time. Now let's create our first function. So we'll create a new function. The sort of keyword for that is new. So func new. And here you have a list of supported triggers. So this is a list of not necessarily a list of supported triggers, but a list of templates for the functions to handle. So there is a blob trigger and Cosmos DB trigger. So blob trigger will actually receive a message from Azure Queue Storage, and it will attempt to download blob specified in that message. So you don't need to do that. You don't need to do that sort of Azure Storage interaction yourself. Everything will be provided by the runtime. Then we have durable functions. Durable functions are sort of latest add-on to Azure Functions that will allow you to have some persistent state behind the scenes. So these are sort of, this is a technique to have Azure functions that might be long-running, might include composing one function from multiple smaller functions, and you want to sort of have a form of orchestration between them, so they sort of provide one by default, so you don't need to, roll it out yourselves. I definitely rolled out multiple ones because there's been sort of, they added it like 2 or 3 months ago. Then you have event grid and event hub triggers. So these are triggers provided by a product called Event Hub. So these are essentially, this is an offering on top of Azure that allows you to aggregate various events from various IoT devices. So you don't need to handle, you don't need to roll out your own event handling logic for various different operating systems. I believe they provide a library that you can just deploy with your application on for Android and iOS, and they will sort of hook into that. Then you have some Outlook messages. So, excuse me, I believe I need to. Is this thing on? Weird. So these are Outlook messages. This is one to handle Microsoft Graph API, and some other ones. The important ones that I wanted to show you is blob trigger, then HTTP trigger, because this is a trigger that gets fired when you specify an API endpoint, and this event gets fired when you have an HTTP request. And then you have queue trigger, which gets triggered whenever you receive a message on the queue, and a timer trigger that sort of gets triggered at specified intervals. So let's start with the simplest one, with the timer trigger. And now, there is a bit of a pickle, because by default it will generate the function as a CSX file. So that's a C# script file. So if I open this and so if I open this, you have apologies for C# code now. I will fix it in a minute. And where do I increase the? So can I? Yeah. So can everybody see it clearly? So, yeah. So this is the function to run, and this is the sort of, where is it? This is the function definition, so a metadata that we have here. So we specify the name of the argument, the type, direction. So this is an input trigger, and this is, for some of you it might be familiar, this is a cron expression, which represents how often the function will be run, with the with one difference is that this is a sort of extended. This is a cron-like expression because it has one more field for seconds. So in this case, it will be run every. In this case, it will be run every 5 minutes, I believe, if we update it to. So this way, it'll be run every 5 seconds. How many of you are familiar with cron expressions? Hands up. Okay, a selected few. So this essentially means that you run it. So if it will be all stars, it will be running every second. this /5 means every 5 seconds. And the way we and if we start the function host, okay, that's weird. So it should complain about not having. Okay. So if I start, okay, now it works. So oh, I haven't saved that file. Okay, so now important thing to mention: the reason why you were installing Azure is that the Azure Functions runtime requires Azure storage to be able to run some triggers. Without storage, it can only run a HTTP trigger. Both the timer triggers, queue triggers, and blob triggers require a connection to Azure storage. And as you can see, the runtime provides hot reloading. When we updated our definition file, it reloaded it and is running the code every 5 seconds. Now here we can add additional message. So the usual hello world message. And now we can see that the function got reloaded and is and the new code is getting executed. Okay, now it's shutting down properly. So before I'll show you how to run and write functions in a slightly saner code. I mean, a slightly saner language than C#, because we can write these sort of functions in F#, and then I'll show you how to write them in Haskell. Do you have any questions? Okay. So bear with me for a second, because I need to find the relevant code. Okay. Okay. Why is it not? Okay. Okay. Sorry for the delay, but for some reason build script is not copying the necessary files. Which is weird. Okay, now it works. Okay. Apologies, there was a bug in the so because there is never enough build systems, this is the sort of build system that's used by .NET, which specifies the project that we're currently building. It sort of specifies that we're using NET Standard 2.0, which is the sort of latest version of framework that we use for building .NET libraries. It specifies the version of Azure Functions, and the sort of important parts is that we have the code for library. So this is the code that the F# compiler will look at and compile, and it also specifies the host JSON file and local settings of the JSON file. The host JSON file needs to always be copied to the output directory, because that's how Azure Functions Runtime tells if it's in a directory that contains files that it can run the Azure Functions application from. And local settings is sort of interesting because it gets copied to the output directory when we test it locally, but we don't copy it to publish directory, and publish is sort of the part of the code that we want to put on a server, because the server will sort of have its own versions of whatever is in local settings. And here is the sort of whatever you want in a function. So for those of you familiar with Haskell and so if you were working with OCaml before, F# code will be really familiar to you. For those of you familiar with Haskell, the OCaml syntax is different in a way that it uses let keyword to bind things on the top level, and it sort of specifies types inline by ascription. So if I were to show you the code, it's so this is a function that will sort of log some information and return and so OK object result will simply return whatever is inside. So if we save that. We can build it, and if we go to, or rather, was it with func host? So there used to be command line switch to specify where the function host is supposed to look for files. I think they removed it in some release. So if you want to start it, you need to go to bin debug nest under 2.0, and here you will have the host JSON file. And if you do func host start, it will start the function host, and it will list the function, the sort of HTTP functions it found. So by default, it starts on the port 7071. The Storage Explorer will sort of mention some activities, just the function host storing its internal data, and now we can send some things to it. So now we successfully run our HTTP trigger. So there are, for those of you unfamiliar with HTTP code, with F# code, this is an annotation. Okay, so maybe I should ask this question: how many of you wrote any bit of C# or F# code in your life? Okay, 3 people. 4 hidden in the background. So I'm not sure if there is anything similar in Haskell. How many of you wrote any Java code? A lot of people. How many of you wrote any Python code? Okay, so I believe Java has some sort of decorators that you can put around the code, right? Yes. And Python has some decorators. So these are just decorators. So this is a decorator around the function, which gives it a name. And this is a decorator around the argument, which tells it that it should be triggered by an HTTP request, and that the authorization level is anonymous, so anybody can send a request to it. And it provides a second argument, which is a trace writer, which is just a class that handles logging. And the runtime will automatically load it, figure out what to do with these things, do all the piping for you, automatically perform some sort of crude dependency injection, and then run the function whenever you send an HTTP request to it. And I will put that code on GitHub now, so you can sort of, so everybody can download it and can start working from here. Now, okay, and there's no git ignore, is it? Okay, so okay, for this sample, I will add you local settings JSON, so you don't need to sort of specify them yourself. But it's not advised to add them. But in this case, we're simply adding. I mean, there are no sensitive information added in there. I mean, there are no keys or anything or any logging data in it. So okay, did not get copied. Okay, so for those of you that want to follow the sample is available at jakzale/monadic party 2018 sample. Okay, so far we saw a timer. So far we saw a timer trigger and an HTTP request trigger. There is one additional one that I wanted to show you, which is essentially dealing with storage queue messages. And so oh, sorry. Here. No, I never remember the annotation for the queue trigger. Was it just the return? Now, if I remember correctly, you can just and this should be enough. Okay, fingers crossed if I remember the right annotation. It's not valid in this annotation. Ah. And so I will publish the sample afterwards, and I don't want to sort of prolong it for too long because I don't remember the actual code to do that, and I apologize for not checking it earlier. But essentially, you can annotate the return value to be either a queue, blob, or a table element. And for other triggers, it can even be an entry in Cosmos DB. And this way, such function executed will sort of put it. In this case, it would put a message on this queue, and if that queue does not exist, it will be automatically created by the runtime. And so then it can be in a subsequent function, it can be consumed in the following way, where you sort of define a third function where here you get queue trigger annotation, and you annotate which queue it came from, and in this case we were putting a string on the queue so we can get a string back. And so if you had, so yeah, let's see. So in a way, this is really cool for quick prototyping, because you don't need to worry about these queues. It'll be created automatically by the runtime. You don't need to worry about actually writing code that will sort of poll the messages automatically. The default polling algorithm provided by the runtime works fairly well. And if any of these functions that sort of trigger on queue messages fails because something happened, the runtime will try to rerun them. It will rerun them by default 5 times. Okay, and if after those 5 times the message will still continue to, the function will still continue to fail, it will create a queue, or if the queue, it will create a queue called sample queue dash poison, and start moving those messages there. So it's sort of a nice sort of backup mechanism to ensure that the application tries to behave as good as possible. And in this case, which becomes extremely important if you use an auto-scaling app, because that one will sort of, if you shove 10,000 messages to it, it will continue scaling up until it can process all these messages, and then afterwards it will continue scaling down. If there would be sort of, if there would be a backup mechanism, you might sort of wake up and realize that there was a regu app or somebody pushed an update that caused your functions to fail, and suddenly it started consuming all available resources that in the data center. And because these data centers are Microsoft ones, there is a lot of resources to consume there. Nevertheless, this is not the exact code. I'll post it online and make it available to you later. But essentially, you simply you can annotate the function return with a sort of annotation to put it in a queue. You can trigger on something appearing in a queue. There are additional. There is something called. So here we are returning one message. You can also pass as an argument a collection to which you can start pushing messages. So you don't only return one, but multiple messages. You can start working in sort of fan out, fan in. Sorry, fan out, fan in is more difficult. So for instance, that one function sort of creates multiple messages in the queue, and you can start working with in a more even sourcing topology when sort of when you generate events as you go. One I'm not showing here because we don't really have time. Is you can write by writing a simple annotation, you can easily get a binding to table storage, so you can start generating events to your to a column-based data store, and you can also generate blobs in that way. So, for instance, the example is that if somebody is uploading a file, you want to store it and then process it. That works fairly well, especially because Azure storage is fairly cheap compared to, for instance, Cosmos DB. And if you're not sure about these things, I believe there are free trials available on Microsoft Azure, so you can go and play with them. And I believe they told me to finish around now. Do you have any questions? And I sort of apologize for a slightly cranky demo. So to yeah, so this is a name of a function in F#. It actually can have any name, because the sort of once you define a name here, it will override that name. And yeah, this is F# code. As I said, I mean, if we were, maybe next year, if somebody actually writes a proper support for gRPC and Haskell, and they sort of stabilize the API for language workers, we will be able to sort of write a language worker for Haskell and sort of have the sort of nice support for scripted functions where if you update the file, it gets reloaded, and that. What's missing? So there are actually two things missing. There's one thing missing on sort of Azure Functions side. Their API for language workers is not stable yet, and this is sort of what I'm showing you only works with sort of unstable versions of Azure Functions. One can attempt and implement that, but if they change the API, that will not work anymore. And the other one is actually finding somebody in Haskell who knows how gRPC works and implementing the language worker. gRPC. So gRPC is a sort of library standard, which is written as an extension to Google Protobuf that sort of standardizes the way how you do RPC calls using Google Protobuf. In a way, it's not directly tied to Google Protobuf, but to serialize and deserialize messages, and you sort of specify your services using Google Protobuf, an extension to Google Protobuf syntax. But the problem is that I found two implementations of gRPC in Haskell, because I mean gRPC is a library you need to do. Yeah, gRPC. Okay. Yeah, you need bindings to it, but I have not found a stable one. And the problem with all these things is that they move fast, but certain certain bits require those things at different versions. For instance, the Azure Functions currently uses gRPC which requires Google Protobuf at version 3.3. The latest one is 3.6. There are some incompatibilities in there. So actually just working with it was just interesting to find out a version of Protobuf that I'll be able to work with and that everybody would be able to happily accept. And yeah. And I believe that's all for today. I will update the code for the samples and show you some actual Haskell code tomorrow, together with the ODL. So this was sort of Azure Functions. I'll show you more about Azure Container Instances tomorrow. That stuff is sort of more easier to use because you just create a container and push it to a container registry and ask Azure nicely to start it for you, and it should work in most cases. Thank you.